Okay, the perennial problem. You've been invited to go to a party or to a restaurant or to a place and you want a bike there. The question is, where will you lock your bike? Is there a reasonable place to lock it? Will it get damaged by cars? Will it get vandalized? Now, there's better and better bike routing apps. None are perfect due to a dire lack of data, but they're getting better and better. For example, Bike Hopper will give you routing instructions that include transit, super sweet, but it will not tell you how to park. And then one of my favorites is Points Mobility, which is available on my phone. A Bike Hopper is only available on the computer, and well, it will not tell me where to park my bike. The sad truth is that the OSM data is not good enough to tell people where to park their bikes or how good the parking is at a given place. What you're looking at here is Oakland. Here's Lake Merritt, and here's two different tests of our bike rack mapping project. Bike parking is super important. If you want to make micromobility the common sense choice for last mile solutions in urban environments, you need to know where you can park your bike, is it safe, etc., 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 etc. So to give you some context, what this all has to do, basically, our goal is to provide micromobility organizations, urban planners, ecologists, etc., with the data they need in order to improve their active transportation network. How are we doing this? Why can we do this? We are doing this using fieldgenie, a tool that we've developed that allows experts to create voice data into structured data. What does structured data mean? Well, I biked around and went and looked at all the bike racks in a particular area. Which area? Correct. This area right here, the green dots. Okay. All right. I biked around and collected all this data in about 40 something minutes. And then I pressed some buttons on my computer, okay, and out came this structured table. And the table tells me what I found, an ID, this is the position, okay, the event duration. Here's the images that are associated with each one of these events. So we found bicycle parking here, and this is the image that's associated with it. Here's the text, the transcript, my speech, what I said when I found it, okay, and then I gave it a score, how good a bike parking situation it is. Okay, some of these are really bad. And it is a U. Notice I corrected myself. Anyway, and then we learn about, let's see, total bike capacity, number of racks present, the rating. Is there a conflict with the curb? Is there a conflict with the sidewalk? Meaning, is it too close to the curb, so if you park a car there, you're going to destroy the bike or destroy the car or not be able to open the car door? Is it so close? Is it blocking the sidewalk? If you park a bicycle here, will you block the sidewalk? And is there a bike currently there? So let's just use this tool here, okay? I don't have this automated right now. We're just going to click on the feature, click on the item, and then see where it takes us. This is going to take us to image number 21. So let's go to image number 21. We're going to go back here, image number 21. And sure enough, this is in front of a nice restaurant, and there's a bike parked here. And what does our table say? What does our table say? It does say there was a bike parked there at the time. Okay, so this also allows you to do a point in time survey of use. And then let's just check a couple more things here. Let's zoom in right here, and let's zoom in right here. And you can see some of the dots are not placed too well on the map. And this has to do with the low accuracy antenna that we're currently using. We can always do better. Oh, that one doesn't have a picture associated with it. This one has two pictures associated with it. Let's go to 58 or 57. It doesn't matter, I don't think. Let's go to 57 or 58. I've clicked on those before. Let's see what 58 does. Sure enough, hoop rack. And 57, as we expected, hoop rack. Okay? And then let's go look at a schoolyard rack just for kicks and giggles. Here we go. Clicky click. Clicky click. And this is number 65. So let's go and look at number 65, which we looked at before. Sure enough, schoolyard rack. There it is. So what's the upshot of this? Well, this is the test 2. Back here's test 1 with terrible symbols. I should improve my symbols. I'm sorry, I'm new to mapping. This is test 2. And we're gearing up to basically map all of Oakland, all the bike racks in Oakland. And I'm looking for people to help with this project, people who will help process the data, people who will help collect data, convert it into an OSM format or something like that. And we're hoping to find someone who has a good bike routing application. I can think of a few names right now who would like to use this data to provide bike users, micromobility users, scooter users with accurate bike parking information that includes the type of rack, the safety factor, is it a good place to park your bike, et cetera, et cetera, et cetera, et cetera. And of course, we can provide cities with point in time bike rack use stuff. The take home here, of course, is that we can do this super duper duper cheaply because of Field Genie, right? We can just bike around, talk, and then take pictures, and bada bing, bada boom, out comes the structured data. So, in summary, hey, you want to map all the bike racks in the Bay Area? You want to set up to map all the bike racks in the United States so that people know where to park their flipping bikes and some safety stuff associated with it? Then please reach out. I'm dying to create this data for the world. Thanks. Bye.